participants. Okay, Farang, you should have the ability to take control.
Okay, hello everyone. Let me bring up my chat box so that I can see what you're typing. Okay, cool. So thank you, Dr. Cleveland, for going over the lab so far. Again, before I get into the notebook, I want to go over two common questions that I received over the past 2 days. The first one is about the quizzes and where you can find them. So actually, if you go to lesson 4, program flow control for loops, while loops, blah, 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 you will see quiz 2 and quiz 3, which I think both of them are due for September 9th. Yes. And something else that I usually do is that if you go to your updates and you choose the course, you will see a list of updates associated with that course, and here you will see, for example, quiz 3. You can open it and do everything you want. So I hope that has answered the question. Another thing was about exporting lab 3 as a PDF, which we have already made an announcement about that. So I hope that is also okay. If you have any more questions, let us know. Now, about your lab 4. Yeah, go ahead.
So how are the quizzes structured?
What do you mean?
Like for quiz 2, it's like about mathematical terms, right? So is it asking like, oh, what does this symbol do and what does that symbol do? Or is it actually?
Well, to be honest, I don't do anything with the quizzes, and
okay.
Dr. Cleveland works on them. So if he is still online, he probably will be a better source to answer your question.
Okay, thank you.
Audrey, what do you mean by practice problems?
Like if there's any like way we can like practice anything before we take the quizzes or like the exams, like is it?
I don't think that there are practice problems per se, but you will have access to lecture videos, lab videos, and all the notebooks and PowerPoint presentations that we covered during the class.
Okay.
Yeah, that will be it, as far as I know. So, I hope that you have all downloaded lab 4, because I have already received a few questions about typos in it. So I want you to open your lab 4. Thank you, Dr. Cleveland. Guys, there is an answer for you from Dr. Cleveland in the chat box. So I want you to go to your notebooks, click on the first cell, add a new cell right below it, and in that, add the information we talked about last session. So for me, that will be something like this. And make sure that you're running that new cell as a markdown, so it will show you something like this, and then edit everything to match this notebook. So the title, the date, your own R number and hex code, and your name. How do we get our hex code? Similar to what we talked about last week. Let me...
Is the hex code unique to every lab? Or can we just copy the same hex code?
Yes, once you run it, it will not change. So your hex code is like your R number. It will be one constant number.
Okay, cool.
So let me actually put this into chat box. So Kyle, instead of the RN, you will go with your own R number, and then with this function, that R number will be converted to a hex code that you can use at the top of your notebooks. Thank you, Dr. Cleveland.
Yeah, I did. I hit return as soon as you did.
So, okay, let us proceed with lab 4. I'm going to move a little faster on the parts that Dr. Cleveland has already explained, both in lecture and at the beginning of the lab. It starts by talking about simple structured for loops. Here was an example. Again, if you are walking through this with me, make sure that you have changed this cell to code. If you want it to run, it shouldn't be raw and it shouldn't be marked down. It should be code. And let's see what is happening here. So first, we are defining a list with 3 strings, Dusty, Aspen, Marry Me. And then we want to simply go through the list and print all the items that is in it. So this is like the most basic for loop that you can get, and it will just do a printout of all the elements in your list. Then we talked about the range function, which is the function that you use to create a sequence by defining its beginning, the end, and the steps or increments to go from beginning to end. Okay. Then the example that follows is count controlled repetition. Let us convert these to code and see what is happening. So what will happen if we run this? It will do exactly the same thing. However, if you notice, there's a difference between the syntax and how we have set up this script and this one. So for this, we are defining a sequence that goes from 0 to 2. You see 3 here, but that's not inclusive. So it will go from 0 to 2 by steps of 1. So it will go 0, 1, 2. And by every count that it does, it will read that element from my pets list. So when it is at 0, it will go to my pets list and read and print out the element in position 0. Then the element in position 1, then the element in position 2. And that will be the outcome that you're seeing down there. Okay. Again, change this to code. What is happening here? In this one, we are using the range function to create a sequence that starts at 2, will end before 6, and will move with the steps of 1. So 2, 3, 4, and 5. So this is a classic way to show you how you can use the range function. The beginning, the end, and the steps. And let's have a look at this one as well.
Hey, Frank.
Yeah.
So if we understand the code by just reading it, do we actually have to put it into code, or can we just keep it as markdown?
Well, if you keep it as a markdown, it will just, let me show you what will happen. It will look into something like this. Because it was not meant as a markdown, it will not look good. You can keep it as raw.
Oh, raw, that's what I meant.
Yeah, you can keep it, but okay. I recommend that you go with code even if you don't want to run it.
Okay.
But actually, I'm glad that you pointed this out, because I wanted to tell something to all of you, and it's that if you are able to look at a script and understand what is happening in it at every line and kind of do an accurate guess of the outcome, that is a very, very good achievement. And just try to remember that you had a very, very limited knowledge of coding before coming to this class. And we are only on week 2. So I think that is very impressive, and I think you will be in a very good position at the end of the semester by covering everything. So congratulations. So in this one, we are printing a Y object that is defined in the range starting from 1, going until 27 by steps of 2. So what you will get as the output are like all odd numbers from 1 to 25. The difference between this one and the previous one was that in this one, we have a step of 2. And I do not really remember, but someone asked during Dr. Cleveland's lecture that what if we only want the even numbers? That will be exactly the same story. So let me go from 2 to 27 by steps of 2, and you will see that I will get all the even numbers in that range. So by playing around with that increment or step size, you can get what you want. Now, for your exercise 1, okay, the last number that you put in is not included in your range. So if you wanted to go to 27, you have to go to 28 when you're defining the range. And then if I turn this back to 1, you will see that it will include 27. Cool. Now, for exercise 1, you know that 1904 was a leap year. And you're asked to write a for loop that prints out all the leap years in the 20th century. I'm going to give you 2 to 3 minutes and see if you can figure this out based on the examples that we just covered. Just a little hint. Dr. Cleveland also mentioned it. A leap year happens every 4 years. So once you know that 1904 was a leap year, every 4 years it will repeat. Chase is asking, does it happen on the year 1900? Yes, it does. And depending on how you are writing your script, it will be included or not. Both cases, you will be right. That is, we are not that picky about it.
If 1900 isn't a leap year, can we not include it?
It is a leap year. We did not intention that you count it in, but if you do, it's okay.
Yeah, I think we skip leap years every 100 years.
Oh, okay. Oh, that I didn't know that. Oh, thank you very much. I learned that right now. So, do we have an answer?
Yes.
Okay, go ahead and tell me what you want me to type, or you can paste it in the chat box if you want, whichever one is easier for you.
Basically, what I did is pretty much for the very last code that we just worked on. That's before exercise 1. We did the same thing. It's asking for the exact same thing.
So let's say for y in range
1900, come on, 1999 or 2000, either one works. Comma 4, and then skip a line, print y.
So with this, it will include 1900. So what if we go in and change that to 1904, and we will get all these. And thank you for all of you who have shared your script in the chat box. Just remember that if you include 1900 when you're defining your range, that will be included as a leap year, and we just learned that that is not true. So make sure that you start your range from 1904 until 1999 or 2000 and go by steps of 4. I keep getting invalid. Why? What is different in what you have typed with what we have typed? So someone that is getting that error. Okay. For leap years in range, okay, that is because you are missing this. Add that and let's see if it works. It works on my computer. Okay, cool. Okay, let us proceed. Then we talked about while loops, and here's an example. We can convert it to code, and actually let us run it and see what is happening. So we define a counter object as 5, and then we are creating a while loop that is valid, that will go on as long as counter is positive. And then we want it to print our counter value, and at each step we want it to go down by 1. So initially it will start with 5. Since 5 is greater than 0, it will print counter equal 5, and then it will say counter is equal to 5 minus 1, which will be 4. Then once again, 4 is positive, counter is equal to 4, counter will be, the new counter value will be equal to 4 minus 1, 3, and it will go on until this counter value is a positive number. Is there any questions? Okay, so,
for him?
Yeah?
So if we don't include that last line of code, that means that the loop is going to be infinite, right?
Yes.
Okay.
Because this is how you are telling it to decrement, to decrease every step. On a similar note, for the next one, we are looking at increment. So we are going with a counter value of 0, and then we are saying as long as the counter value is less than or equal to 5, we want you to print the value and then add 1 to that. Okay? So let us convert it to code and see how it runs. It starts from 0 and it goes up 1 by 1 until it reaches the condition that we have defined. Now, if we remove this equal, what will happen?
Only go to 4.
Exactly. And something else. In this line, what if we just say counter plus equal 1?
Same thing.
Something.
It will be exactly the same thing. That is because this sign to Python, it means that at each step, add this value on the right side to the previous value of the object. That is just a contract. You will not probably see the same thing in other languages, or for example in R. So this is exactly equal to its previous form, which was this. Any questions? Okay. Now, we will move on to talk about break. Break function is used whenever you want to... so you need to be plus equal 1 and then remove everything after that. Max, Blanca, are you getting the right one now? Okay. So I'm going to leave this format here because you already are familiar with the previous one. So we use break whenever we want our loop to exit at a certain condition. So for example, in the example that we have here, if we turn that to code and run it, you will see that we are starting with a j value of 0. Then we are defining basically a counter in the range that starts at 0, goes until 5, not reaching to it, by steps of 1. So this is counting 0, 1, 2, 3, 4. Okay? And then for each step of the counter, we want our j to be increased by 2. This is exactly the same format as we talked over there. And then once that happens, we want it to print the I value, the I equals to the I value, and then j equals to the j value. However, if and as soon as our j value gets equal to 6, we want our loop to be broken and stopped. So what is happening here? For I equal to 0, j will be 0 plus 2 equal to 2. For I equal to 1, the next step, j will be 2 plus 2 equal to 4. For I equal to 2, j will be 4 plus 2, 6, and since this condition is met, the loop is broken. Is that clear? you want your loop to go as long as a certain condition, and then when that happens, you want it to be broken. Look at the next one, changing it to code and running it. In this one, you see that you have all your counter values 0, 1, 2, 3, 4, and all the j values associated with that, which is computed based on this command. You still have a break command built in your loop, but it never gets activated. Why is that?
Because it was odd, or skipped over, or jumped over.
Because you are saying that I want to break whenever my j is equal to 7. Will your j ever be equal to 7?
No.
No, and that's why that part of your loop will never get activated, and your loop will never be broken.
Why did it stop at 10?
Why did it basically stopped at 4 because you defined your counter in a range of 0, 5, 1, so it basically goes 0, 1, 2, 3, 4 and stops. If I change that to, let's say 8, let's say what happens. It will do all the counts because j will never be equal to 7, hence the loop will never be broken.
So this is a good technique to after errors?
Exactly. So we will talk about that more, but let's say you know that for one specific condition, your loop will have an issue or will not produce the right outcome or whatever, and you want that specific condition to not happen. So you will define your code in a way that as soon as that happens, the code will be broken. Before that, it will work. After that, it will work. But at that certain condition, your loop will be stopped. Doesn't make sense?
Yeah, that's pretty cool.
So let us move on. And we are going to talk about nested control. Let's convert this to code and see what is happening. Okay. This is the first time in our class that we are going to sure. Thank you, Dr. Cleveland. So this is the first time in our class that we are going to use a package. Packages in Python or in other programming languages like R bring you certain predefined functions that may not be accessible in basic Python. And you just need to import that package. Or one of the advantages of Python is that if you have a package that it has 100 predefined functions and you only need 2 of them, you can go and only import those 2. But let's not talk about that here. So let's say that I want a table that has on one column that has degrees or angles. And on the other side, it has the cosine associated with those angles. The cosine function is something that we can get from a package called math. So by this line here, I am importing a package called math. And that package contains the cosine function that I want. So that is what the first line is doing for us. Then I want to create a table. So if I run this, it will probably be easier for you to see what is happening. So this is a table that we are creating by this script. What is happening? On the first line of the outcome, we want to print spaces, spaces, space, cosines, spaces, spaces, space. That is exactly what you see on the first line. Then on the second line, we want some spaces, x, some spaces, a divider, some spaces, cosine of x, and then some spaces. So that is the second line. Then we want another horizontal divider, so we will print this. And then, since we are actually getting to our computations, we want to define a range that goes from 0 to 156 by steps of 1. That will be our counter value I. Then I'm saying that my I is equal to my I value as a float number multiplied by 0.001, or basically divided by 1,000. And then I want to print that like this. The reason that we are formatting this print like this is very similar to the three on top, because we want it to look nice and look like tabulated in our outcome. So whatever value is computed for x will come here. Then we will have some spaces and a divider. Then we will put the cosine function from math package. That's how it will be read. So from math package, the cosine function will be applied on the value of x. Now, let's see what we have. Our first counter value was 0. We turned that into a float, and then we multiplied that by 0.001, so still 0. The cosine of 0 will be 1. Then, for the next counter, I goes to 1. We will convert that into a float and multiply that by 0.001, so that will be the value of x. And the cosine of that will again be 1. Since my counter goes from 0 to 156, my x column will go from 0 to 0.156. And on the right-hand side, I will have the cosine value associated with each x value. Do you have any questions? I actually have a question for you. If we wanted to go from 0.000 to 0.156, why didn't we define our range like that? We could have asked for a range that starts at 0, goes to 0.157 with a step of 0.001. Is that right?
Steps can't be fractions.
Very good. That is one of the limitations of the range function. And it looks for integers for increments. And what has been done here is a very smart way of going around it. So you are getting the range that you want, but you need to modify and manipulate the outcome of the initial range function. So let us see what is happening with the formatting of our table right here. Initially, we want the first line to be just like the table title. So it will be some spaces on both sides and the title in the middle. So this is the first line here that is printed right here for you. Then, on the second line, you want the right column side and the left column side. So you have your spaces, x, then this divider, which is here, and then Braden, do not run ahead. And then on the right-hand side, for the heading, you have cosine of x. Again, all these spaces and these dividers, the way we are formatting this table is because we want it to look like an actual table, even though this is all text. So we have to modify it in a way that it looks the way we want. Then on the third line, we are simply adding these as dividers. And let me just show you what will happen if I add like 4 more dashes. See, it looks hideous. That's why it was in the format that you saw. So then we do our computations. And this here again is something that Dr. Cleveland already mentioned. This percentage sign and these numbers with F, I have already put that in our chat box earlier, but I'm going to do that again. So the F stands for the floating point, which means that the value that is going to be after that will be printed as a real number. And then the number that comes, like here we have 0.3, that is the number of decimals after the point. That means that the real number that we have already defined using that F will have 3 digits after the point. You see? And then we will put the value of x, a divider. The format for y is going to be different. We are putting 4 numbers after the digit. That's why here you're seeing percentage sign 0.4f. Here it was 3, here it's 4. And then you just put in the outcome of the cosine function from math package applied on the value of x. And that will give you this long table of x and cosines of x. So let me have a look at the chat box and see if there are any questions with this. No? Okay. Now, let us move to exercise 2. Some of you has already, what does the percent mean between percent 0.3 and f and x? What do you mean? You mean this one? Okay. Dr. Cleveland, I think the text messages that you sent are coming privately to me, okay, and the rest can't see it. But Dr. Cleveland just pointed out that that percentage is a placeholder to associate with the X number. Yes, there you go. Thank you very much. So, as some of you has already pointed out, we have a typo happening here. In exercise 2, you're asked to write a Python script that takes a real input value, or a float number, for x, and it returns the y value according to the rules below. So, if the x value that you... Is anyone talking to me?
It was like an echo.
Okay. So, if the x value that your user gives is somewhere between 0 and 1, you want your y value to be equal to that x. So, if your x is equal to 0.5, then your y should also be equal to 0.5. If your x value is somewhere between 1 and 2, you'll want your y to be equal to x to the power of 2. And then if your x is greater than or equal to, you want your y to be equal to x plus 2. So actually, we want to remove this, I guess. No. Yes, we are good.
Okay.
What did you do?
I just went ahead and removed this part from the end of the third statement.
Oh, okay.
So now it is telling you that as long as x is a number greater than or equal to 2, you want your y to be equal to x plus 2.
Okay, got it.
Now, I'm going to give you another 2 or 3 minutes. I want to see what you will come up with.
I have a question.
Sure.
On the exercise 1, on the last one, where we use the math package.
For this one, this was not an exercise. This was just an example.
Example, okay.
Yes,
so
we
use
the math package.
Oh yeah, we can get those if you want to use other equations, math equations. So we can get those like the way we wrote it, math.cos x. Like instead of cos x, if there is other trig equation we want to put it.
You mean if you bring in the cosine package, the cosine function from another package?
Yeah.
Let's say that you are importing a package called X, okay? And in that package that is called X, you have some function, some cosine function. If you want to run that function, it should be x.cosine, because that's how you're telling your notebook, you're telling Python that you want a function to come from a certain package. Did you get it?
This one.
So actually, let me add this here. Name of package dot function. It's the right. So in the chat box, fire alarm. I hope you're all safe. If you guys live at U-Lofts, then that is every day. And Jacob, you asked if we need the math package to use float numbers instead of integers in the range. No. Exactly. As I explained, Jacob, here in the cosine example, you will see that we had to do this little trick because in the range function we cannot use float numbers for the steps. So you need to, for exercise 4, if you are already running ahead, you need to come up with another way to trick your notebook. Range will not work with float numbers, regardless of whatever package that you import. And thank you, Dr. Cleveland, for covering the chat box. So, for exercise 2, do we have a volunteer or someone who wants to see if they're doing the right thing? Okay, let's start with Leanna's, see what is happening. So she is asking for user's input, and she's pretty strict on the user, so she's only giving them 4 choices. This will not be a critical issue on your script, but generally you can just ask for a number, and then if you want to test your script, you can add those 4 or whatever numbers that you have. So then she wants to go and say, if x is greater than or equal 0 and less than 1, print x. Else, if x is less than 2, print x to the power of 2, and else if x is equal, okay. Let's run this. I will go with 1.1. And it is giving me the right value. So this is working just fine. Very good. Something that you could do was, since you have 3 conditions, for one of them you will use if, for the next one you will use else if, and for the third one you will use else. But that's not a deal breaker because your code is working pretty fine. And then you can be a little more descriptive with your printing. So you can say, for example, y is equal to, and then put your x value. Or here you can say y is equal to your x2 value. And then now if I run it, it will tell me that. So you can make it look more user-friendly and welcoming. But the content is there and it's working. Now, what if the input is 0.5? Let's run it again. It will say that y is equal to 0.5.
That's right. Okay.
Which is correct. I'm not sure why Dr. Cleveland asked that, or if that was a question for your script or not. So let me just make the script I have on my screen a little more consistent. And here I'm going to ask, please enter an array. Then if we go with, let's say, 2.1, we'll say y is equal to 4.1. Yeah. So generally, when you are asking for input, you don't want to limit the choices of your user. You want to go for general input.
question.
Sure.
So I know on exercise 2 it says test the script for each of those values. Do you want us to like copy it every time and show you that we tested it, or just show at least one of them?
Well, what we want or basically what I'm going to look for when grading this will be if your script is functioning and you can just report your tested values as a markdown, or if you want to be a little fancier, as a table. So that will be open to interpretation by you.
Okay.
If you have a working script, then reporting those 4 values should not be a big hassle.
Okay.
So, I'm going to move on to exercise 3. Exercise 3.
Mine doesn't work for some reason.
You have the exact same thing?
I think so, yeah.
Paste your script in the chat box and let me have a look at it. Okay. Let me create a new cell. So, the reason that it's not working is that you are saying if the condition is there, you want it to print y is equal to y, but you have not defined a y object in your script. So you basically want it to be x to the power of 2, and x plus 2. Then Dr. Cleveland says that the printf statements are not built correctly. Yes, you have one extra parenthesis here.
That should work.
Let's see if it works now.
Yep.
How do you type into the power?
You mean this one?
Yeah.
That is something that we covered, I guess, in the second session. That's how you tell Python that you want a number to go to the power of another number. Yes, lesson 2 operators.
How did you put it to the power? I just forgot how to do that.
Double asterisks.
Brayden says that there is nowhere to turn in this lab.
There we go.
So, no, you're not blind. Dr. Cleveland, can you please create the link that they can upload their lab assignments? Thank you very much. Dr. Cleveland is working on it. So, I'm going to delete the cell because that was just something we were working on with Esteban. So, for exercise 3, using your script above, add functionality to automatically populate the table below. Since I want to show you something with another package, I'm going to do this myself. And then I'm going to ask you to create a table with the traditional way that we have already discussed in the cosine method. So, here is the script that I have written for this exercise. And I'm going to tell you what is happening at each step. I need a function called prettyTable from a package called prettyTable. So this is how you will go and import a function from a certain package. If you remember, in the cosine example, we imported the entire package, and then we used the function by saying math.cosine. In this one, since I only need one function from that package, I'm going to say from pretty table import pretty table and mind the formatting of higher and lower cases. Then I'm going to use that pretty table function to create an empty table with headings of X and Y. That was an elephant on fire, I guess. So here I'm defining okay. I'm going with T as the name of my empty table. Then, looking at what the question is asking for me, it wants me to change X from 0 to 5 by steps of 1. So I will create a counter that goes from 0 to 6 because I want 5 to be included. And then by steps of 1. Then I'm going to apply my rules. Your script do not have to be identical to mine. This is just how I did it. It's not the only way, or it's not the best way. So I'm saying that if my X number is greater than or equal to 0 and it's less than 1, then I want my Y object to be equal to X. Then I'm going to print for X equal to the value of X, Y is equal to the value of Y. And then I'm going to add a row to my empty table T by saying T dot add underline row, and then the value of X, the value of Y. So this is probably the new thing for you at this moment. Initially, my T table was defined as an empty table. Now that I have my first value for X and first value for Y, I'm going to T dot add underline row because I want one line to be added to my table. And then I'm going to say X and Y. And this will add a row to my table T. My next condition. If X is greater than or equal to 1 and less than 2, then I want my Y to be equal to X multiplied by X, or X to the power of 2. Exactly the same thing. Now I want an identical statement. I want to print that for X equal to X, Y is equal to Y, and I want the X and Y pair to be added to my table T. And if none of those conditions are true, I want my Y to be equal to X plus 2. And then the same thing will be printed and the couple will be added. And then at the end, I want to print my table T. Let's see what happens. These are the sentences that I wanted to be printed. So for X equal to 0, Y is equal to 0. For X equal to 1, Y is equal to 1. For X equal to 2, Y is equal to 4, and so on. This is my table T. You see, my X and Y. So initially when I created my empty table T, this was the only thing that I had. Then eventually at each step I added a row to my table with the values of X and Y. Can you copy it here for the pretty table? I'm going to give you this. And Dr. Cleveland just mentioned that you can learn more by Google search Python pretty table package and use examples or something similar in the search. Should find a blog from someone with good examples. Actually, let us go and do it together. I'm on Edge, so it doesn't bring up Google on its own. So, pretty table Python examples. So I just opened 2 of them. This one is a pretty table tutorial. I'm going to give you the link. And it basically tells you how to install the package, how to generate a table, and actually the table that you can see in this example is even bigger than ours. It has 4 columns and several rows. And then some functions that you may find useful here. In our example, we used add row. You can go with add column, you can go with delete rows, delete columns, and stuff like that. So you may find this quite interesting. And this is another link from programcrick.com, and it has some examples as well. So if you Google, you will find many resources that can help you, and that is, if you ask me, that is the most important thing that you need to understand about programming, to rely on Google and to find good forums, good weblogs, and good resources that you can go to. No one, or at least to my knowledge, no one knows everything and every command and every function and every package in a programming language these days, because they are so vast. So you just need to learn how to search and find answers for your questions. So this was my answer to exercise 3. What is happening? See me? You're getting that error. So if you create a new cell and you just run this, the first 3 lines, what will you get? Yours just automatically jumps from 0 to 6. Esteban, that is a good question. Ask that again once I'm done with this. So, Dule, are you sure that you're creating your range in the right format? Because it shouldn't jump. Did you copy paste my script? Can you, Dule, can you paste your entire cell in the chat box? What is this invalid? That is not my code. Why do you want your Y to be invalid? A little different format, but the same concept. Okay, let me run it and see if it gives me any errors. It runs on my computer. It runs on my computer, but it is very weird because it goes from 0 to 6 and then 1. Oh, okay. You have a few things here that you don't really need, like this one. you're already defining a counter. Yes. You're already defining a counter and you don't need this anymore. And then Dr. Cleveland is saying that your X is a tuple. Let me run this.
Go ahead, type X, see what you get. Use a type function. Oh, it's an integer.
Yes,
it was that
integer.
It's missing the word range in the for loop.
Yes,
so I thought it treated that as a tuple.
You see, now it gives you 0, 1, 2, 3, 4, 5. And it is giving you invalid because you have told it that if X is greater than or equal 3, it should be invalid. But we didn't ask that in the question, so.
Actually, that was pretty good because you realized that when X equals 3, Y became a string, so you didn't attempt to format the string as a float. So that's actually fairly impressive. Good job.
I copied back the edited text so that you can take it. Someone else had the issue of jumping as well. Yeah, that was Dule. Probably... Okay, so
go over my response to copying code. It's a while back in the chat. So if they copy code,
yes,
acknowledge it, attribute it, and I'm trying to think if I have an example on the server because I've done that myself. And what I do is I attribute it code below, copied from, do your best attribution, and since you're getting it from the internet, you'll have a URL. Put the URL in the comment line. That's about the most honest thing we can do. And
yeah, then that really goes back to how similar the thing that you are doing is to the script. So if you take something and you modify it so much, that will be a little different than
at some point
exactly copy pasting.
It becomes yours if you modify it enough, but I don't know what enough is.
Yeah.
So, I mean, I have a linear solver that I copied. I changed a single line of it to make it work right, but that doesn't make it mine, even though it was a fairly substantial conceptual change, because I changed something that was doing association to direct replacement. Huge difference in how it worked, and actually that it did work. But I don't claim that as my own because I really can't. But it has an attribution, says taken from https:// and then whatever the URL was, and that's the most honest way you can do it. Most modern tools have tons of other people's code in them. Your smartphone has code that was made by Oracle, Sun Microsystems, Apple, Samsung, the GNU project, which is open source, and buried deep is it acknowledges that. So for the time being, that's my treatise on borrowing code.
And the way I think Liana's answer probably resolved your issue, but for anyone else who is still a little confused, for any value greater than or equal to 2, the third statement applies that says y is equal to x plus 2. So that's the rule that you want to go with. Now, as I said, we've covered exercise 3 with the pretty table, but that is not the only way. We have already talked about a way of formatting a table, so you can actually go ahead and run your own script for exercise 3 and format your table using what you had in the cosine example. Okay, let us move to exercise 4. You want to modify the script above to increment the values by 0.5 and automatically populate the table below. So here we are going from 0 to 5 again, but at each step, instead of going by 1, we're going by 0.5. And the trick to this is the range function's limits in using all the integers. So, Esteban, what was your question? The video is being recorded, so you can always go. Oh, okay. Dr. Cleveland's explanation on using someone else's code. Yes. You will find the answer both in the chat, and then he explained it also that you can find it in the video. So I'm gonna give you 2 or 3 minutes to tell me what can we do for exercise 4.
For Hank?
Yes.
Do we have to just do float x times 0.5 before x in range?
Can you come again? I had some issues hearing you.
I'm just saying, so you know the function that we use for cosine exercise? Like x is equal to float x times 0.5. Since you said that the increment don't work for it only works for the integers, just multiplies by 0.5. Is that?
Yes, actually, what you need to do is quite similar to what you saw here in the cosine example, and something else that Dr. Cleveland had in his scripts here. So if you look at these scripts, it should give you the right idea for tackling exercise 4. Dule, you're getting very close.
Can you change the range from like 0 to 55 and increment it by 5, and then multiply your x's by 0.1?
Okay, do we have someone who wants to give me their script, or we are still on the theory? Okay, Liana. So let's see what Liana has. So you want to have a handmaiden table. You'll go with x divider y of x. Then you're going to print your horizontal divider. Then for x in range of 0 to 55 by steps of 5, if your x is between 0 and 10, you will multiply it by 0.1. Let me run this. You know what? This is working. And it is working. The answers are correct. The only thing that I have to say about it is that it could be written a little more easier. But I think your idea is right and your script is working just fine. So, very good. Then let me see what Dule has. A new cell. So he wants to create a format table. He goes for a range of 0 to 11. Then he converts that to a float and multiply it by 0.5, and then he runs his code. And that is pretty good. Very good. So Hunter has also sent a script. Let's have a look at that. So what he's doing is he's using pre-table, my kind of guy. Then he's going with the same range. Beautiful. Very good. Then we have Rame. He has done pretty much the same thing. Very good. Guys, I'm really proud of you.
Nice.
And I think you got the hang of it. Mark, Steban. I'm not gonna run all of your scripts in the chat box, but if you think that you have done something different from what I've already shown from the other guys, let me know. I'm really impressed because these are the building blocks for coding in engineering, and I think you are getting the hang of them, and that was the whole goal. Very, very good. So we have less than 10 minutes to go, so let me get to exercise 5. On exercise, before we actually get to exercise 5, we have to try accept a structure. And if you thought, I'm not again remembering the name, but someone were saying that the break function is very cool, this is even cooler. So basically the syntax is try to do this, except do something else. And we use this when we can foresee our script running into an issue or an error. For example, if we want to do multiple actions of similar type, let's say dividing. We have a list of 100 numbers and we want to divide them by a certain number. And we know that at some point we are gonna we're gonna have an issue of dividing by 0 or the wrong kind of input or something that we feel may cause us some problems. Then we use the try except structure. Now, let's have a look at this example. So, what is happening here? We are saying that x is equal to 12 and y is equal to 12. Then we are creating a while loop and saying, as long as y is greater than or equal to minus 12, try printing that x is equal to x, y is equal to y, and x over y is equal to x over y. But since we know that going from 12 to minus 12, there is a point that y will be equal to 0, we know that this will have an issue at that point. So we add this part and say except print error divide by 0 in that case. And then y should go one step down because we are going from 12 to minus 12. So at every step, we want our y value to be reduced by 1. Now, let's see what is happening. In the entire thing, our x value is equal to 12 because once we define it as 12, we are not changing it in the entire script. Our y value, however, is going down by 1. So it starts at 12, as you can see here and here. And then it goes down by 1. So 11, 10, 9, so on, and until it gets to 0, and then goes from minus 1, minus 2, minus 3, into minus 12. and it is calculating the value of x over y at each step, and this step where y gets equal to 0 is the only one that is different, and it's the only one that you're getting the error divided by 0. That's because of the structure that we have built in this script. If we do not have that, let's see what happens. It will give us an error because it will not be able to complete the loop.
Actually,
so,
that's you need to comment out the try also.
Oh yes.
And then push print to the left. I think one. Yeah, there you go. Perfect. That gives you
again,
the proper
as you see,
error.
It runs for the values that it can. So y equal to 12 until y equal to 1 runs. And then it will give you 0 division error, float division by 0, and it will not continue going on with the loop because of the error, the loop is broken. How does it know when to implement the error statement? Here, let me go back to the way it was. Okay, here we're actually telling it that as long as you can run this and try this, and when you can't, go with this. So does it just execute the accept statement when it encounters an error automatically? Yeah.
Yes.
Yes. So again, to show you how cool that is, so it will not, it's not going to do a miracle and compute that value for you. What it does is that it helps your loop to work for as long as it can. So you are still getting your negative values of y, and the only one is the y equal to 0. If we remove that, as you saw, your loop will only get to this point, and then you will get an error. So that is the benefits of using the try except structure. What do we have here?
That one generates the error. You've already done that.
Oh, okay. Okay. So, and for exercise 5, we have 3 minutes to go, so I'm going to leave this for your homework, but let's see what it is asking. It is saying that modify your exercise 3 script to prompt the user for 3 inputs: the starting value for x, and the increment to change x by, and how many steps to take. Your script should produce a table like this, but the increment can be different from 1 as above. Include error trapping that takes any numeric input for x or its increment, but forces that into a float. Takes any numeric input for number of steps and forces into an integer. Takes any non-numeric input, issues a message that the input needs to be numeric, and makes the user try again. Once you have acceptable input, trap the condition if x is less than 0 and issue a message. Otherwise, complete the requisite arithmetic and build the table. Test your script with the following inputs for x, x increment, and number of steps. So basically, what you are asking your user to give you is your range, but you are asking it in a different way. So you're asking 3 questions. Where to begin the starting value for x? What is the size of the step, increment to change x? And how many steps to go? And when you are testing your script, these are the 3 values that you will need to put in to test your script and see if it's doing the right thing. And there are 3 error trapping, and this could be a hint, but I think you already figured that out, that you need to use the try except structure. So that's all I have for the lab today. So even if you had code with different types of errors, Dr. Cleveland has already answered that. Anyone from Cam1107 add my snap? That's not about us, I guess. So if you, yeah, go ahead.
So the one you just skipped, the one is the code.
This
that's
one
right after 5. Yeah. Mm-hmm. If you run it, I get an error. Are we supposed to find what's wrong with it or what?
This is exactly why we use the try except structure. So this is exactly the same example. We are saying that our x is equal to 12, our y is equal to 12, and while y is greater than or equal to minus 12, we want you to print the value of x, value of y, and the division of x over y. And then at every step, reduce y by 1 value.
Scroll
so
down to
as you see, it starts at 12, 12, and it starts going down until it reaches x equal 12, y equals 0, and then it will give you this error. So yes, you were supposed to get this error and see what would happen if we had not used the try except structure.
So should I just create it, change it into some markdown? So that way it doesn't give me an error when I try to...
turn it back to raw.
Pardon?
If you turn it back to raw, it'll clear the error. Scroll down to the error part. Well, I didn't want you. Go ahead and rerun it, please.
Sure.
Okay, so part of the error stuff is to actually read it, because sometimes they're useful. So this one, 0 division error, it's pointing to where it occurs. It's just told you the error you've made. So that's really handy, and you can get your script to work correctly. Other errors, admittedly, make no damn sense, and you have to do some more detective work. I've got to end the call now, so I'll be doing that in like the next minute. Thank you all for your attention. I think today was a good day. Have a safe weekend. Monday is Labor Day, and we were supposed to make you watch some kind of safety video. Basically, try not to get infected. Be careful. And we will see you on Tuesday.
Yeah, keep away from the COVID-19 and fires in your dorms.
Yeah.
And parties.
Okay, well, goodbye, everyone.
Take care. Be safe. Bye.
Goodbye.